This is a webinar series sponsored by the ERC project Facets, which stands for Face Aesthetics in Contemporary E-Technological Societies. The PI of this European project, Massimo Leone, affiliated with the universities of Turin and Shanghai, is a semiotician. Today he is in Belgium, so unfortunately he couldn't join us. We'll see the recording later. And he was interested in exploring how the technology affect the way in which we conceive, perceive, represent, and share face and face representations. I give the presenter mode to Ben, and I thank him wholeheartedly for having accepted our invitation, and I hope that we can have a nice discussion after your presentation, and thank you very much. The floor is yours.
Wonderful. Thank you, Marco. I'm very excited to join you all today and tell you about some of the work my lab has been doing over the past several years to investigate how artificial faces of many different kinds are recognized and perceived perhaps differently in some ways than real faces. So let me just get my slides going for you here. Just a moment. And let's go to the beginning, of course. Okay. Hopefully everybody's seeing everything now. Excellent. Okay, so my talk for today is entitled Between Real and Unreal, the Perception of Artificial Faces. And I chose that language between the real and unreal because one of the things my lab is very interested in is the nature of this boundary that exists between perceiving a face as real and recognizing that a face is some kind of artificial agent. And I'd like to motivate all of this by just saying a little bit about why my lab is interested in artificial faces in the first place. And I have to say, it's something I feel more of a need to justify in recent years as the technology for making artificial faces has improved so much since we began doing this work. So I'm going to be showing you a lot of faces made with commercially available software for rendering artificial agents of different kinds. But of course, there's much better tools out there than I can afford, right? So if you look at the entertainment industry, this is even an old movie now. Alita Battle Angel came out several years ago and really had impressive CGI technology for rendering this wholly artificial protagonist in the form of Alita, who, of course, has some interesting distorted features. That's something we can talk about later. But on the whole, looks like a pretty plausible artificial being that, inhabits this movie and engenders all kinds of feelings of sympathy and determination and all this. And I should say, I'm complaining about the cost of expensive CGI technology, but there's inexpensive options available these days for making very convincing artificial faces too. So the face here on the right, I actually just generated yesterday evening at this somewhat remarkable site called thispersondoesnotexist.com. This is a site that has a generative adversarial network that will create random images of photorealistic human faces for you. So this is not a real person. This is an image generated by an artificial network. And so you may wonder, given that we're at a point in terms of this technology where we can make these faces that look so real, you really have to scrutinize the face on the right to see some of the fine-grained errors that it makes to tell that this is an artificial face. What I'm showing you here turns out to be one of the characteristic errors these networks make when they try to create artificial faces. You can see that the pupil has this implausible shape to it. And this turns out to be one of the only ways that these generative networks trip up. But given that this is the level we're at in terms of making faces that are difficult to distinguish from real ones, what is sort of the point in studying real and artificial face perception, especially with these somewhat clumsier models I'm going to be working with today in my talk? Well, this is sort of my lab's perspective on why artificial faces of many different kinds are interesting from the vision science perspective. And really, our interest in these starts with this observation that real human faces are special in terms of both behavioral and neural responses. And what I mean by special here is that the way we process images of real human faces seems to be fundamentally different than the way we process other objects in our environment, things like cars and houses and chairs, all the other stuff that populates our visual world. I'm just showing you two somewhat related examples of ways that face images are processed differently than objects here that are sort of part of my toolkit for convincing people that faces are an interesting stimulus class, both of which sort of focus on this idea that one way we process faces that's different than objects is we process them as wholes. We do something to the entire image rather than breaking it down as parts to try and recognize and perceive different properties of the image. On the left, I'm showing you an example of holistic processing of the face in the form of something called the inversion effect. So we know that if we turn faces upside down, they are much, much harder to recognize than when they are right side up. And this is not true for other classes of objects in general. How bad are you at recognizing features of upside down faces? Bad enough that you probably haven't noticed the extreme violence we have done to this face on the left through something called the Thatcher effect, which you may have seen before, but this is a particularly dramatic illustration of it. If I turn this face right side up, there we go. You'll see just how horrible this transformation is that we've made to the face, right? What we've done is we've flipped the eyes and the mouth upside down inside the face outline, and your processing of that image is so inefficient when it's upside down. While maybe you can see that there is something strange going on, it certainly doesn't look nearly as grotesque in that upside down image as it does in the upright one. On the right, I'm showing you a subtler effect related to this sort of holistic processing of the entire face image. This is something called the composite face effect. And the story here is that it's very difficult for observers to just recognize parts of a face. You sort of have to process the entire face image at once, even if I give you explicit instructions to just focus on one part of it. So the trick I'm playing in these images here is that the top half of all three of these images in the top row are identical, but by placing different bottom half images underneath the first two, those top halves to many observers start to look different. It sort of appears to many observers that there are differences between the top halves simply because there is a bottom half that differs between the two images. And we take that misperception as evidence that your visual system is doing something to sort of glue together the whole image, even if you're given the explicit instruction to try to just fragment this thing and recognize it. So behaviorally, faces stand out from other objects because we don't see these same kinds of effects for other classes of objects. In terms of brain responses, which I won't spend a ton of time talking about today, but I can say more about our work in this direction if you're interested, we also know there are dedicated parts of the brain and signature brain responses that also are unique to faces. So what I'm showing you here on the left are the potentials that we measure using EEG, electroencephalography with sensors on the scalp, in response to faces in the red line and other classes of objects in blue and green. All you need to worry about here is that this red line is much, much larger when we show you a face than when we show you other objects, which we think reflects the activity of some face-specific parts of your brain that we can also identify with fMRI, which I'm showing you over here on the right. So not only are faces processed in these fundamentally different ways by your visual system, they're also processed in fundamentally different places in your brain. We think you have dedicated neural machinery for doing various kinds of face recognition tasks. So there is a way that faces stand apart from other objects. And to my mind, that makes artificial faces a very interesting thing to study in terms of trying to work out what that boundary is like between faces and objects. Because to me, that's really the question about these behavioral effects and these neural effects that separate faces out from objects. The question for me as someone who cares about the visual system is really, what is it about this stimulus class that makes it different? What is sort of the criterion that your visual system is using, that your cognition is using to say this image counts as a face and thus is going to be processed by these distinct mechanisms in my brain and using these different cognitive mechanisms? And this is an interesting and complicated question. There are a lot of things that it seems like sort of count as a face to your visual system, even though they are obviously objects as well. What I'm showing you here on the left are some sort of funny examples of pareidotic faces, the kinds of face-like stimuli that sort of strike you immediately as having enough face-like structure that you almost can't help yourself but sort of infer the presence of a face-like pattern here. If you look at these things on the left, Marco and I were just talking about this before the talk began today. It's almost irresistible to look at these images and see emotions in them, maybe start to infer personality in them. But from my point of view, the real interest is that you see these patterns and something in your mind very quickly attributes face-like qualities to them. And we can see this in terms of some behavioral results like the ones I talked about, and also in terms of some of the neural data from places in the brain like the fusiform face area. What I'm showing you here on the right is that this part of the brain that responds to real human faces, well, it's not just real human faces it responds to. It responds to the faces of other species. It responds to extremely schematic faces that don't have near the personality of these things on the left. And even though that response is weaker, it's still greater than the response of this area to objects. So there is something about this boundary between a face and a non-face that is complicated and sort of makes room for interesting variability in what a face might look like to be considered a face by your mind and your brain. And artificial faces, I think, are a fascinating tool for examining sort of the shape of this boundary because they give us a lot of hints at just how complicated it is. And so one example of a complication in terms of thinking about what this boundary might be like is this effect I'm guessing many of you are familiar with called the uncanny valley. And the short version of the story regarding the uncanny valley is that sometimes when we try to make an artificial face that looks pretty convincing, it goes horribly, horribly wrong. So these are images from a CGI commercial some years ago now for a brand of popcorn, Orville Redenbacher's brand popcorn. Mr. Redenbacher himself passed away many years ago, but they decided to digitally resurrect him for a commercial about 5 to 10 years ago. And they made this truly unsettling CGI version of the man that just horrified viewers everywhere. And the thing people say about this face and many other uncanny ones is it just looks wrong. It looks like you've reanimated a dead person. It looks sort of waxen. It's creepy. There's some mistakes you have made in creating this image that make it seem not face-like or maybe not agent-like enough to convince your mind or your brain that it should be processed the way a real human face is. And to me, this is interesting because there are many things we're getting objectively right about this person's appearance. You can recognize who it is if you know this real person, but there's still missing perceptual features here that mean it engenders these feelings of sort of creepiness and unsettlingness. On the other hand, whatever mistakes we're making here, as unsettling as they are, other kinds of distortions aren't so unsettling. So here's an example of two patterns that I'm sure you think look pretty face-like to you, that you probably think look relatively pleasant. These are aesthetically enough pleasing faces that they're part of popular media. And they are much more distorted relative to a real human face than that image I just showed you in the previous slide. But somehow what we're doing to these images in making, the outline of the head a different shape or the eye size much different than it should be doesn't lead to that same feeling of grotesqueness and that unsettling feeling that sort of rules the stimulus out as a face. So just intuitively, this suggests to me that this boundary between a real face and an unreal face must be very complex and probably determined by multiple perceptual, cognitive, and maybe social factors as well. And to me, that makes this really rich territory to try and understand this distinction between faces and objects that your visual system makes. So that's very much the goal of the research I'm going to talk to you about today. And it's something my lab continues to think about in a number of different studies that we have ongoing. So here's what I want to talk to you about today. I sort of have three main parts to the talk. First, I want to say a little bit about some of the first work my lab was doing to try and understand how artificial faces are categorized. And that means both how do we decide to categorize an image as being artificial, as opposed to real, but also how do other categorization tasks that we perform with faces interact with the perceived animacy or the perceived artificiality of face images. And it's really a question about how these different bins we can put faces into may be sort of confounded with each other and how that may drive responses, biased responses in particular directions. After that, I want to say a little bit about the social perception of artificial faces, which is something my lab got very interested in a few years ago that we continue to think about. The question here is how the differences in appearance between artificial and real faces may lead social inferences about personality to be made differently. Again, perhaps in some systematic ways that depend on other face categories that we use to generate appropriate behavioral responses to face images. Finally, if we have time, I'm hoping to tell you a little bit about some of the new directions my lab is going in with regard to robot faces. Most of the work I'll talk about in the first two sections has to do with either computer-generated faces or images of dolls that are both explicitly human-like. But in our most recent work, we've been starting to think about faces that are decidedly not human-like. These are sort of plastic metal robots that have very different facial appearance than human faces, but nonetheless are often perceived as perfectly acceptable social agents. We're sort of starting to look at some of the properties of how robot faces are perceived, and again, how these sort of cognitive and social factors may affect the way we make inferences about robot faces. So let me start by saying a bit about artificial face categorization. And I want to start by introducing this idea from vision science called categorical perception, which is sort of at the heart of what I'm thinking about when I talk about categorization in the context of visual recognition tasks. This phrase categorical perception, what it means in vision science is really it's referring to this phenomenon where in some cases, for some classes of stimuli, gradual physical changes in the stimulus are perceived by the visual system in terms of these sharp boundaries or categories that sort of carve up a continuous spectrum into these discrete bins. And one, I think, very nice example of categorical perception at a low level of the visual system is simply the way we perceive color. The physical wavelengths of color across the electromagnetic spectrum, those vary continuously. So if we talk about the difference between a violet light and a red light, the physical variable we're changing as we go from violet to red is the wavelength associated with that light. And this can vary continuously from very high frequency light that looks blue or purple to us to very low frequency light that looks red to us. But what's interesting is that despite that gradual transition from purple to red, when you look at something like a rainbow, where the physics of what's happening mean you're seeing that continuous spectrum, we still perceive that in terms of these discrete colors. So we talk about the 7 colors or the 6 colors of the rainbow, not this sort of continuous spectrum from purple to red. We impose these boundaries between these nameable colors, and those boundaries have consequences that affect the way we discriminate and categorize the stimuli that represent a way our visual system is sort of drawing lines for us on this continuous spectrum and using those lines to make judgments. It turns out that we can think about that same kind of principle with regard to how artificiality is perceived in faces too. Now, I don't have a sort of real physical stimulus like light to play with here, but we can create a continuous transition between real and artificial appearance by using some tools from computer graphics. And this is an image from this really nice paper by Lusser and Wheatley in 2011, where they examined what they called the tipping point of animacy, or what they were really looking for was evidence of something like a sharp boundary between real and artificial faces, despite the fact that they were creating images that transitioned gradually from an image of a real person to the image of a doll that they blended it with. And what they found in their work is that indeed, as you gradually change the appearance of a face from being 100% doll-like here at the left to 100% human-like over here at the right, eventually you reach this steep boundary where very rapidly observers change their mind in terms of labeling this face as being artificial or being real. And they examine this both by explicitly asking people to categorize animacy, but also by asking them related questions about things like, could this face have a mind? Could this face have its own intentions? Could it feel pain? All these different proxies for agent-like behavior and sort of being a real person led to the same steep boundary between real and unreal. And so this is one of the sort of core things my lab got interested in many years ago, sort of taking the existence of this boundary as a chance to play a little and ask about what perceptual features contribute to the boundary and what factors might push this boundary different directions. Lusser and Wheatley gave us some interesting things to think about in their paper already. In particular, in terms of perceptual features, they examined using subjective ratings what parts of the face seem to be most closely related to the steep boundary between real and unreal that you see reproduced here in this sort of blue-purple line. And the gist of their work was that the eyes seemed particularly important. So if you look at this green line here for the kinds of responses people make about these morphed faces when they only get to see the eyes, you can see the boundary here remains pretty sharp, and that line is not as sharp when people only get to see the nose or the mouth or just the isolated skin of these patterns as well. So the idea from Lusser and Wheatley is that there is a category boundary between real and unreal, and really it's the appearance of the eyes that is mostly responsible for that steep drop, or I should say steep increase in real responses as you approach the real appearance of an actual human being. In my lab, we sort of thought this was interesting, and we wondered about things like, what happens if those features are placed in conflict with one another? Can we get a sort of finer grained look at how different features contribute to this decision about animacy by making the different parts of the face disagree with one another? So to do that, we carried out a study using morphed images like Lusser and Wheatley created of our own, where we carried out what we called eye transplants. So we start by making these blended faces where we are mixing together human appearance with doll appearance. And we, again, can sort of find this steep boundary between real and unreal responses with a midpoint that's shifted just a little bit towards the doll end of the spectrum. But then the trick we're going to play is, instead of presenting the eyes or the other parts of the face in isolation, we are going to transplant in either human eyes or doll eyes to all the images across this spectrum. So while the rest of the face is going to gradually transition from doll-like to human-like, we are going to just put 100% human eyes on all of those images, or put 100% doll eyes on all of these images. And the question now is, how is this boundary affected by just the appearance of the eyes? If the eyes really do carry most of the information about animacy, well, then maybe this boundary will disappear. Maybe the presence of the human eyes everywhere will just make you say, great, there's eyes that look human, this is a human face, I'm done. And vice versa, there's doll eyes here, now this is a doll face, I'm done. Instead, we see something more interesting. The results of these transplants are, I think, neat in two ways. First, we see that changing the appearance of the eyes does nudge our results in some predicted directions. So putting human faces into these morphed images makes you more likely at all levels to call a face real. But we still see a spectrum of responses between artificial and real. It's not like the eyes erase this boundary. Likewise, doll eyes also make you respond in a more artificial fashion across the whole spectrum. But what's really fun for us here to see is this asymmetry, which I've expressed here in terms of saying it's easier to take the animacy out of a face with this kind of manipulation than it is to put it back in. And what I mean by that is you can see this huge gap over here at the right between the impact of human eyes on our images and the impact of the doll eyes on our images with the blue line. There is a huge animacy cost to putting doll eyes into a real face that is not matched by the improvement of putting real eyes into a doll face. And what I think this suggests is that it's not just the eyes that are driving your perception here. It has to be the case that these other parts of the face are contributing to this judgment, and they contribute in this way that's sort of biased. Hints of artificial appearance sort of, if you want to put it this way, sort of corrupt the rest of the image very readily. Small amounts, a small area that looks inanimate makes the face look dramatically inanimate or artificial, and that same little drop of real human appearance doesn't have the same impact. You can't make an artificial face look much more real just by putting in a little bit of real appearance, but you can do the opposite. You can make a real face look very fake by putting in just a little bit of artificiality. We also decided to further examine the contribution of other parts of the face to animacy judgments by using a technique called contrast negation to specifically look at the contribution of skin pigmentation to animacy judgments. Contrast negation works. It's a pretty simple technique. What we're really doing is just flipping the intensity of all the pixels in our image. So everything dark becomes light and everything light becomes dark, which leads to these funny sort of photonegative images. You know, it's funny, I feel like I can't call them photonegative anymore because no one uses film. But if you're old enough like me and you grew up with actual film in your cameras, you might remember seeing photographic negatives, and that's basically what we're creating here. Contrast negation is interesting because that flip in the brightness of all of our pixels is known to specifically disrupt the way we perceive texture and pigmentation in the skin. And so to the extent that skin also contributes to judgments of artificiality, negating the face should also greatly disrupt the way that animacy is categorized in these faces. But the further trick we play is again with our eye transplants and creating these images that are called contrast chimeras, where we have photonegative skin, but positive eyes dropped in, or the opposite, negative eyes dropped into positive facial features. I don't want to drown you in data here, but the punchline of this story here is that the skin also does turn out to play a very important role in determining whether you label a face as artificial or real. So while Lusser and Wheatley made this case that really the eyes carried most of the information about whether a face looked real or not, we found in a couple different studies that really it's many different parts of the face that carry that useful information. And the skin in particular does turn out to make a big contribution to whether you think a face looks real or not, which is maybe not surprising if you talk to people who do computer graphics, because they will tell you one of the hardest things about making artificial faces that look convincing is getting the rendering of the skin right. Skin is a really interesting material in terms of the way it interacts with light, and that makes it very difficult to render well for characters like Alita that we saw in that first slide. If you don't get that interaction of light with the skin correct, it looks very much like wax or plastic, and this leads to these kinds of uncanny perceptions we want to avoid in entertainment applications. So this role for the skin that we identified here got us thinking about some other categories that we apply to faces that we also know depend critically on these contrast and brightness relationships in the skin. And in particular, it got me thinking about some work from one of my good friends and lab mates in grad school, Richard Russell, who's done some really lovely work about the way we perceive sex and gender categories and how that depends on particular luminance relationships in face images. I'm showing you an illusion Richard created several years ago now that illustrates this very nicely, that he calls the illusion of sex. The trick in this image is that you are seeing exactly the same facial features on the left and on the right, but my guess is that most of you probably feel like the image on the left looks more male and the image on the right probably looks more female to you. The only thing that is changing is the lightness of the skin. So the male-looking face has slightly darker skin than the female-looking face over here on the right. And this turns out to be a true mode in the data out in the world. Cross-culturally, men have darker skin than women. If you measure it carefully, like many anthropologists have done, you'll find that men everywhere are slightly darker than women. And this leads to these characteristic contrast relationships between the skin and the mouth and the eyes that it turns out your visual system uses to make categorization judgments about masculinity compared to femininity. Okay, but these contrast relationships in the skin also affect how animacy is perceived, which led us to wonder whether or not animacy might be itself gendered. That is to say, does male versus female appearance affect the way you judge animacy? So we asked how you perceive animacy across the same kind of blended morph continuum from real to unreal when we compare the responses of male stimuli to female stimuli. So we can make male morphs between real and unreal and female morphs between real and unreal and ask how categorization works both for artificiality judgments and for gender categorization. So we can start with something really simple. Let's just ask people to tell us how real faces look across this continuum and separate out the responses to male faces from those to female faces. And something really interesting we found at once is that when you look at these subjective ratings across all of our morphed images, women are reliably rated as less real looking than men. So even when you're talking about a photographic image of a woman compared to a photographic image of a man, that real image is going to be rated as less alive if it's a picture of a woman than if it's a picture of a man. So this suggests there's some kind of interesting relationship here between sex categories and animacy categories. We can also look at this with some other subjective ratings to see that it's not just the case that gender affects how animacy is perceived. The artificiality of a face also affects the way gender is perceived as well. So again, these are subjective ratings. We're still getting, we are looking at our continuum of faces from human to doll-like as we move from left to right in each graph. On the left, I'm showing you how judgments of masculinity and femininity change to male and female faces in the blue and green lines respectively as we move left to right. The thing to notice here is that for both faces, as we become more doll-like, we also start to look less masculine, which shows you there's some kind of confounding between the sex categories and artificiality. And this also has impacts for how attractiveness is perceived. So male faces and female faces cross over one another in terms of attractiveness ratings as we move from more human to more doll-like, probably consistent with this idea that if you look more doll-like, you look more feminine. And more feminine female faces look more attractive than more masculine female faces for most observers. And the reverse is true for our male faces. So not only do we see this impact of gender on whether you think a face looks real or artificial, we see an impact of artificiality on these sort of proxy variables for the sex categories. Because we're sort of a psychophysics lab, at least some of the time, we did want to know how this plays out in sort of a true categorization task. So besides asking people for these subjective ratings, where we're just saying, 1 to 7, tell us how real the face looks or how attractive it looks, we wanted to use a categorization task where they were making speeded responses to our images across this continuum and just trying to tell us whether each face was male or female as quickly and accurately as they could. And this, again, led to some really interesting and kind of dramatic crossover results, where what we see is that male faces are most difficult to classify correctly when they look artificial, but female faces are most difficult to categorize correctly when they look the most real. So as you become more human looking, your performance at correctly saying that female faces are women begins to drop rather severely. On the other hand, your performance with male faces improves pretty dramatically as those faces look more real. So again, this suggests that artificiality is sort of tied up with looking feminine for the stimuli that we used here, which suggests you have some interesting influences between these categories. And I'll say just briefly, we can also see this in the response time to these judgments as well, which again reflects this sort of confounding between the category female and the category artificial. So what do I think this means? Well, there is this meaningful category boundary between the real and unreal that we can measure in my lab, but it's determined by multiple perceptual features. So the eyes, the skin, many different aspects of the face contribute to that boundary. And it also turns out to be a boundary that interacts with other categories we maintain about faces. And here I've talked about the relationship between animacy and gender, but there's also reasons to think that things like age probably matter a lot here too. Like artificial faces may look systematically younger than real faces, and we may see similar kinds of confounding between old and real and young and artificial that affect the way you make judgments like this in many different tasks. Okay, so from here, I'd like to move on to saying a little bit about social variables and how they are perceived in artificial faces, because this is sort of a different class of category judgments we make about people. So besides inferring things like whether it's a real face you're looking at or not, or whether someone's a man or a woman, we also estimate many different social variables when we look at human faces like these. I have to give you one of my favorite examples of this, which I always tell my students about because it's sort of hilarious, but it also points out how relevant this sort of impression formation literature is to real world behaviors. So this is a picture of a man named Martin Shkreli, who is infamous in the United States for his business practices in the big pharma industry. In particular, he's known for doing these sort of horrible things with price fixing and raising the cost of prescription drugs for personal profit. And he was being prosecuted for these financial crimes some years ago. And before his trial began, the prosecution and the defense are able to select the jury that's going to decide his fate. So the prosecution and the defense are each allowed to dismiss some number of potential jurors based on things like previous bias towards him. If someone in their family had been hurt by these practices in the cost of medicine, maybe they'd be excluded. And the thing about Martin Shkreli is his face is sufficiently off-putting that the defense ended up dismissing many, many jurors just because people would come in, take one look at him, and say things like this. This is juror number 52, who's an older woman who was being interviewed to be on the jury. And she says, when I walked in here today, I looked at him, and in my head, that's a snake. Not knowing who he was, I just walked in and looked right at him, and I said, that's a snake. And of course, the defense dismisses her and says, so much for the presumption of innocence, right? And clearly, this is a very strong first impression she is making from his face that now has these real consequences for the way he's going to be prosecuted and possibly sentenced for these alleged crimes he committed. So you make these judgments all the time. These judgments matter a great deal. What do we know about how you do it? Well, there is a great deal of work examining the relationship between the physical appearance of the face and the perception of these social variables, a ton of it from Alex Todorov's lab at Princeton. And they've done some really lovely work trying to work out the sort of dimensions of what they call a social face space, and how the physical measurements you make, the face images, predict where an individual face sort of lives in this face space that they typically describe as being spanned by these dimensions of trustworthiness or valence on one axis and something like dominance on an independent axis. The idea is that these dimensions are sort of fundamental to the way you socially evaluate face images, and they build this elaborate model where they can take a picture of a face and predict how trustworthy or dominant they think it is going to look to you based on the physical measurements they can make of that picture. But one thing about this that Marco mentioned in his introduction is a lot of this work depends very heavily on using these artificial faces that they can control very carefully and get these detailed measurements of. And to my mind, there's a real question there as to whether or not that means any of this work is valid for real human faces, right? Given all the things I've just told you about, you may worry that imposing artificial appearance like this maybe starts to change what's happening in terms of the way we perceive this image enough that the things we predict about artificial faces and how they'll be perceived might not match up with the way real photographic images are going to be perceived. So this is something we were really interested in unpacking a little bit and asking whether or not artificial appearance affects the way you socially evaluate faces and whether artificial faces and real faces share a social face space. Do they sort of live in the same places in this, this trustworthiness dominance space? So we did this work by not using these morphs between doll faces and real faces anymore, but trying to make a direct comparison between real photographic faces and artificial images. So we took some real faces that we had in the lab. These are actually all people I went to college with, which makes this kind of funny to do. But then we made artificial versions of all of them using this proprietary software called FaceGen. And just to show you briefly how this works, you start with a real photographic image like you see here in the lower right, and you basically mark a series of landmarks on the face in a front view and in these profile views. And when you're done marking out where all of those different landmarks are, things like the tip of the nose, the bottom of the ears, the jawline, FaceGen then is able to take the lightness information from the photograph, the position of those landmarks in all three images, and generate for you a 3D model of what that real human face looks like in their morphable artificial space. So we did this for all my college friends. So we had this nice stimulus set, and we decided to start with a simple study about how trustworthiness is perceived in real and artificial faces. Does the artificial appearance of an image affect the way you perceive the trustworthiness of that face? So we brought some participants in and we did something really simple. Again, we just started with subjective ratings. We showed them our images that were either real or artificial versions of the same people. And we said, just 1 to 7 scale, tell us how trustworthy this person is. And just both to replicate previous work and to sort of test how closely they were paying attention to our faces, we also gave everybody a surprise memory test after they had done this rating judgment. So after they tell us how trustworthy everybody looks, we say, hey, surprise, we're going to show you some faces. Some of them will be the ones you saw before. Some of them will be new. Try to tell us which ones were the old ones. The interesting thing about this work is that, first of all, your memory for artificial faces is just systematically worse than your memory for real faces, which by itself is kind of interesting, but somewhat unrelated to this question about social variables. But I do want to mention it just so you kind of keep it in your head. What about the relationship, though, between how you estimate trustworthiness in the real and artificial images? Well, there is a significant correlation to the tune of an R of like 0.5, which means we're explaining like 1/4 of the variance in our data from the real faces using the artificial faces. But the really cool thing that we see out of the scatter plot is that our computer-generated faces overall are rated as looking less trustworthy. So imposing artificial appearance on our images makes these faces look systematically less positively valenced. They look less like you can trust them. So already that's kind of an interesting hint that artificial appearance does matter in terms of how you assess some social variables. Like in our previous work, though, we decided we wanted to do something that wasn't purely a subjective rating, but also include more of an objective sort of categorization task as well, to see what happens when you have to make a sort of, I guess you could call it unbiased judgment about trustworthiness under psychophysical conditions. So rather than provide a rating in this task, we instead ask people to make ordinal judgments about trustworthiness using either pairs of real faces or pairs of artificial faces. So the idea here is that having measured how trustworthy our real faces look in our first experiment, now we can set up a situation where we're showing people 2 images at a time, and we know which one of these faces should look more trustworthy than the other. And what we're going to do in this task is show people either 2 artificial faces or 2 real faces, and we're going to ask if they get the answer right. The prediction is if looking artificial disrupts your ability to measure these social variables, you should be less able to correctly identify the more trustworthy looking face when you see 2 artificial faces than when you see 2 real faces. And indeed, that's what we found. Accuracy in this task, the who looks more trustworthy experiment, was significantly lower when faces were artificial than when they were real. So again, this shows you that making faces look computer generated or artificial, it does something to disrupt the way you estimate these social variables. In particular, it makes you less efficient or just less accurate at distinguishing between a trustworthy face and a less trustworthy looking face image. Okay, but remember, Todorov talks about this whole space, not just trustworthiness. He talks about all these different sort of variables, including dominance, sometimes including competence or attractiveness, that they use to talk about the social properties of a face image. So we also wanted to do something to try and look at that entire space all at once and sort of compare the kind of social face space we might create from artificial faces to the social space we might create from real face images. So to do that, we need to actually build a social face space for artificial faces and compare it to one that we build for real images. So how do you make one of these in the first place? Well, what Todorov does in his lab's work and what we do in ours to replicate his results is create a bunch of different face images like the ones I showed you and ask people to rate them on a number of different properties that are all personality variables. So you can see here the 14 different measures used in Todorov's original paper. These are the ones we used as well. We asked one set of observers to look at all of our different real faces, a different group of observers to look at all of our artificial images, and just for every picture, give us a 1 to 7 rating about all of these properties. How aggressive does this image look? How intelligent? How confident? So on and so forth. So that we have 14 numbers to describe each image, both for its real version and its artificial version. What we do next is use that data to create the dimensions of a social face space using this analysis technique called PCA, or Principal Components Analysis. I don't want to drown you in the technical details here, but the bottom line is we're using those 14 numbers we got from those separate ratings to try and come up with a way to arrange these images in a space. Ideally, a space that we can describe using only maybe 2 numbers or 3 numbers instead of all 14 that we started with. And the axes that cut through that space are now hopefully going to be these sort of fundamental properties of personality, or the social estimates that explain most of why that original set of 14 numbers changed from one face to another. The more technical way to say that is we're trying to find ways to rotate this space so that we're capturing the most variance in ratings across different images for all of those 14 numbers. Another way to think about it is we're looking for relationships between these 14 variables. We want to find out things like perhaps trustworthiness ratings always correlate strongly with responsibility ratings and caring ratings. If we know that those things are highly correlated, we probably don't need to measure all 3 of them. We can probably just measure one thing that reflects how all 3 of them are going to change at once. So we take our 14-dimensional ratings, we carry out principal components analysis, and indeed, we end up able to create these separate social face spaces for real faces and artificial faces. And the question is, how similar are they? Do we have the same kinds of axes that cut through them in both cases? And are faces positioned in the same place when they're rendered in photographic appearance versus rendered with artificial appearance? I'm going to focus on that second question about position in the face space, because it's sort of the easier one to talk through and show you results about. What we did here is basically ask whether the position of an image in its real social space, the one we created from our real photographs, to what extent was that position correlated with its position in the social space we created from the artificial images? Okay, so it's a way of sort of saying how the relationships for all of these dimensions at once are sort of related or not between the real versions and the artificial versions of the face. So we can look at our first dimension, which turns out to be trustworthiness, and our second dimension, which turns out to be dominance. And what we see is that there is a positive correlation between the position of real faces and artificial faces along the trustworthiness axis here on the left. But of interest is that there is a negative correlation between real and artificial faces for dominance. That is to say, the more dominant you looked as a real face, the less dominant you are going to look as an artificial face, and vice versa. Whereas for trustworthiness, the more trustworthy you looked when you were real, the more trustworthy you will look when you were synthetic. Now, because we saw in our previous work that gender categories interact with animacy, we thought this difference in the direction of these relationships was a nice reason to maybe look at male faces and female faces separately. And this is where things get really interesting. What I'm showing you now is that same real versus artificial face correlation, but broken down for my male faces on the left and my female faces on the right. And I'm showing you trustworthiness in the top row and dominance in the bottom row. What's interesting to see here is that the correlation between real and artificial faces for trustworthiness turns out to be almost entirely driven by just the female faces. So female faces are strongly correlated for trustworthiness across real and artificial appearance, male faces not so much. On the other hand, that negative relationship for dominance turns out to be driven almost entirely by the male faces. You can see that male faces have this significant negative relationship between real and artificial appearance for dominance, and female faces have no relationship at all. So again, this kind of shows that when we're inferring these personality variables, they are also gendered. And because animacy is also gendered, that means that artificial appearance interacts with these personality variables in a way that depends on these sex categories too. So, oops, hang on. So all of this suggests that relying on these artificial faces to make inferences about the way social face perception works, it's pretty dangerous. There's a lot of reasons that we suspect a lot of that work won't apply directly to real faces, probably because of some of these underlying confounding variables between what it means to look artificial and also what it means to look more feminine or masculine, or possibly to look more young or more old. All of these things influence one another, which means that the way you infer personality is going to be different when you look at artificial faces compared to real faces. Okay, I see I am a little short on time here, so I'll just quickly talk you through some of the new work we're doing with robot faces, and what I think they have to offer to us in terms of thinking about artificial face perception more broadly. For now, though, I do want to leave you with this idea that personality variables are definitely perceived differently in artificial faces, probably because of these other categories and how they all interact together. But on to robots. So I already told you why artificial faces, why robot faces in particular. Well, in terms of this boundary between real and unreal, I like robot faces a lot because they are explicitly object-like in a lot of ways, despite the fact that they're also often very social agents. We can sort of infer a lot of personality and intention from robots, despite the fact that they can look really different to us. So here's just a selection of different robots from pop culture, and also robots you can just buy for yourself. The little guy on the left we have in my lab here. We have a small army of these little Boxster robots that are kind of fun to play with. I mean, just look at the sheer variety in these images. Some of them don't even really have faces at all, right? R2-D2 here just kind of has some lights in some places, doesn't really have a mouth. Robot arms don't have a face at all, right? But we can easily perceive robot limbs like this to have some personality and to have intention. Which I think suggests that there is a strong social contribution to some of the perceptual categorization tasks we might do when we think about robot faces. Just briefly, one of my honors students last year got interested in thinking about robot faces and what makes them look uncanny sometimes, and how that uncanny appearance might affect perceptual encoding of those faces. So my student, Ali Geiger, did this really nice work looking at the way uncanny appearance in robot faces might affect face memory. And she was able to take advantage of this very nice database of robot images created by Mather and Riesling in 2015 that already had tons of metadata about things like mechano-human resemblance, likability, tons of different subjective ratings for all these different kinds of robots, spanning a continuum from creepy to not creepy, to very robot-like, to more humanoid looking. And Ali was first of all interested in how their metadata would correlate with our own estimates of uncanniness. This is just to briefly show you that when we asked observers to rate how uncanny faces looked in a memory task, the uncanniness ratings they gave us correlated strongly and negatively with likability, which suggests these two variables are very strongly related. And you can also see that we have this interesting U-shape relationship between uncanniness and how mechanical versus humanoid our images look like. So that's all to say we're sort of effectively measuring the uncanny valley in our experiments. But what Ali was really interested in is if you ask people to study these images, are the most uncanny looking faces remembered more or less effectively than the least uncanny robot faces in the data set? And I'll just briefly tell you that the upshot of her thesis work is that it turns out the more uncanny a face looks, the better it is remembered. So at an item specific level, Ali found that there was this nice relationship between memorability of a face and the uncanny appearance of a face. And that is a relationship that is not predicted by deep neural networks trained to predict the memorability of images in general. So this is using Wilma Bainbridge's ResMem architecture, which is a deep neural net designed to work out how memorable images of anything, landscapes, objects will be. Their net does not predict how memorable our uncanny faces are. So whatever features make pictures in general more memorable don't tell you about what specifically makes uncanny face images memorable, which again, I think harkens back to this idea that faces are different than other stuff. There's specific perceptual tools we use to recognize them that we really need to find out about in detail to understand how all of these things interact in real and artificial face perception. So that's really what I have to tell you about today. And I hope I've convinced you artificial faces are interesting for us to think about as vision scientists, in part because of the nature of this category boundary between the real and unreal, which turns out to be affected by many different properties of face appearance, and which in turn affects the way we make judgments about personality as well in multiple different ways that my lab is still continuing to explore. I will just say quickly, we think about all of this stuff in the neural domain as well. So we have tons of brain data we can tell you about sometime too, if you're interested in. This is some of my student Ali's ERP data about neural responses to robot faces and real faces. But really, I just want to stop and acknowledge the many students that contributed to this work. These were all students who were undergraduates or even high school students at the time of working in the lab. And did great work for us helping to explore these issues. And also thanks to our technical staff at North Dakota State in the Center for Visual and Cognitive Neuroscience, without whose expertise we probably wouldn't be able to do most of the work that we do. And thank all of you for your attention.